We live in an age where we are reliant on space travel. From navigation to communication, Earth science to astronomy, space has become the home for a wide range of technologies that have revolutionized the way we live. But with new satellites being launched almost daily, have you ever wondered how high they are going? How far do you need to go to say you have truly reached space? The answer is tied directly to our atmosphere. At the bottom is the troposphere, the layer in which we live. From clear skies to thunderous storms, most of our weather is produced within this region, and it's where many commercial planes fly. While visible and radio light can reach this layer, most other types of light are blocked further up. The stratosphere directly above is actually hotter than the troposphere, despite being further from the warmth of the Earth's surface. This is because gamma rays and X-rays are absorbed by the gases in this region. It's here where you find the ozone layer that protects us from the harmful ultraviolet light of the sun. About 50 kilometers up, we reach the mesosphere, the coldest layer. It's here where most of the meteors that fall into our atmosphere burn up. These rocky fragments, the leftovers from comets and asteroids in our solar system, produce brilliant streaks of light in the sky, commonly called shooting stars. The Karman Line is where many, including NASA, consider space to begin. Named after Theodore von Karman, he calculated that at this height, the atmosphere is too thin for normal aircraft to fly. They would have to travel at orbital speeds to keep them in the air. Rockets like the Boeing-built NASA Space Launch System are needed to exceed the Karman Line as they have enough thrust to leave the Earth's orbit. Now we have reached the Thermosphere, the hottest layer. It's here that one of the most spectacular Earthbound phenomena occur, the Aurora. Charged particles blown off from the sun are curved towards the poles by the Earth's magnetic field and interact with the gases in the atmosphere, producing brilliant shimmering curtains of light. Above these we find GPS and communication satellites, along with the International Space Station. These are all still within our atmosphere, meaning every now and then they need a push to keep them from slowing down and falling out of the sky. It has taken the efforts of many organizations to build, launch, construct, and operate the International Space Station. Our atmosphere never truly ends. It becomes thinner and thinner through the Exosphere, a layer that extends at least 10,000 kilometers up until it is all but undetectable. We still have almost 370,000 kilometers to go before we reach the moon, and many millions of kilometers further before we reach even the closest planet. So in the grand view of our universe, space is only just above your head.